right. Welcome, everyone, and thanks for joining us here today. Today, I'm going to be talking about the transition and learnings from Dark Forest to Mud. I'm Gubsheep. I'm the creator of Dark Forest, alongside a handful of other folks, some of whom are in this room, including Ivan Chubb and Alan Lowe, as well as many other contributors to the project over the years. For those who aren't familiar with Dark Forest is a decentralized MMORTS game built with ZK snarks on Ethereum. Under a couple of different metrics, it was sort of the first complex, fully on-chain game. And it led to a whole bunch of really interesting innovation and a lot of super interesting both research and practical directions. At its core, Dark Forest is a space conquest game. Players are basically dropped into an ever-expanding procedurally generated universe. You spawn in a home planet, you conquer nearby planets, you accumulate resources, you go to war with or make diplomacy and trade with other players nearby. One of the key features of Dark Forest was its programmability. Namely, because it was built on-chain, it was client agnostic. It could be modded both at the client and at the contract levels. And we saw basically that a huge part of the Dark Forest culture and gameplay eventually emerged around actually modifying the game and customizing your own game experience. And we saw tons of really cool emergent behavior from this. The other really cool component of Dark Forest was the incomplete information aspect of it. Basically, Dark Forest was the first on-chain game to introduce a fog of war. In other words, when you spawn into the universe, you don't know where other players are, and the only way to discover the locations of points of interest nearby to you is essentially to hash the universe and traverse it using zero-knowledge proofs. So that's a little bit of an introduction to the Dark Forest game. It started in 2019 as a little bit of a pie-in-the-sky experiment. It didn't really even initially begin as an attempt to actually make a real playable game. At the time, me and some of my collaborators were learning about Ethereum and zero-knowledge proofs for the first time, and we had an idea for a project of let's build a ZK space game proof of concept where every essentially like WASD move were to trigger a transaction and a ZK snark proof on chain. And at the time, this was a pretty absurd thing to try to do. Each such transaction would cost millions of gas, and this did not seem anything remotely close to the realm of possibility. But a lot happened since then. It turns out that this was just barely on the edge of feasibility for both Ethereum/EVM-based chains as well as for zero-knowledge proofs. Over the course of 2019 to 2022, we saw over 10,000 players from around the world participating in Dark Forest rounds that spanned over 2 years, using trillions of gas collectively on Ropsten and then XDAI chain, which eventually became Gnosis chain. We developed a rich developer ecosystem where people were coding plugins, alternate clients, GPU miners, player corporations, data marketplaces, chain analysis tools, and more, all to get an edge in the game. And we saw epic on-chain dramas featuring deception, betrayal, redemption, and more. So a lot has also happened outside of Dark Forest since 2019. In particular, if you're at this conference today, you've probably heard about Lattice and Mud, which started as an on-chain game engine and grew into an application framework for EVM-based programs, and as we just saw, potentially even to something much, much broader than that. We've also seen this rich ecosystem of games, including OPCraft, SkyStrife, Words3, this Cursed Machine, Draw.tech, Primordium, rollups, app-specific chains, all sorts of infrastructure. It's safe to say, basically, that this idea of more complex on-chain applications that explore a more broad spectrum of the design space is something that is very actively under development today. So yeah, we've got this flourishing ecosystem of a bunch of really cool stuff going on. So the focus of today's talk is a little bit of a retrospective, a comparison of then and now that should hopefully also give some insight into how we got here today and how some of the major I think patterns in the space have developed out at a development level. So back in 2020, I met Justin and Alvarius, who started collaborating with us on Dark Forest. Justin actually built a couple of the core features of several rounds of the game. And they eventually set off on a journey to build, as Alvarius just showed in a screenshot, ZK Dungeon, which was an additional on-chain game. And that line of experimentation eventually led to Mud. And today, if you look at the Mud introduction on the developer docs, you'll see basically this in the opening. Mud evolved out of our experiences building on-chain games like Dark Forest and ZK Dungeon. We identified many difficulties along the way, and these revealed the need for a framework and a protocol to handle the inevitable complexity of game code and to counteract the developer-unfriendly patterns inherent in the way smart contracts are traditionally written. Now, if you've used Mud or an application development framework in the last year, you have probably had both your fair share of like aha moments around like, oh, this is really cool that I can do this so easily. And you've probably also had your fair share of perhaps frustrations as bugs are being ironed out. But what I want to do today is talk a bit about like what was development like in the world before these kinds of application frameworks, and how did those problems really motivate what tools like Mud are solving today. So again, we're starting in this world in 2019. Our deployment tool is Remix. For those of you who are familiar with that, there is basically just like, Solidity and Yule. Let's start off by trying to write the planet struct. So this is a Solidity struct that encapsulates the notion of a dark forest planet. All right, so here's the planet struct. It's got like a couple of different fields. It's got the planet's owner, various stats. Planets can produce resources. Planets have a level. And over time, we just started adding more stats as we added features to the game. And then we encountered the fabled stack too deep error. So it turns out, for esoteric reasons that I actually can't even remember now, if you start passing structs around that have more than 13 properties, you run into an error. So what do we do when we want to add more features? Well, we've got planet extended info. So planet is now two things, planet and planet extended info. All right, so, Kushaba's rolling along, adding all sorts of different mechanics here, upgrades, space junk, etc. And then he runs out of fields again. So we're at 13 fields. So what do? Well, we get planet extended info 2. Now this is really awesome because, we've got like this thing, planet data, which is essentially holding like, and then there's this revealed chords thing. So you sort of have this like annoying thing. Now you're managing how these three things are running around and try to reconcile them all across your code base. And eventually, we found some workarounds with this. After 3 years of development with planet extended info 2. Okay, so, that kind of brings us to things like the ECS model. The ECS model, Entity Component System, which was one of the core insights behind the first version of Mud, was sort of pulled in to simplify this. So, entities can be attached to, can have various different properties. These properties have some sort of abstraction that's used to represent them, and it's just like a lot easier. Like this is a configuration file, and it's just so much easier than having to manage structs that can have a maximum of like 13 properties. Okay, so all right, we've got our planet struct. It's 2020. Now it's time to start writing some getters. So let's write some getters. One thing that we have to know is like we do have some emergency functions here for the first couple rounds of Dark Forest in case things go awry. We've got, get snark constants. We've got this thing where, there's in-game items called artifacts that you can get by like finding them on planets, and they can only be found up till a certain time. So you have to be able to get that timestamp. There's some game constants. You're also going to have to get the planets. And because you've got planet extended info and planet extended info 2 and revealed chords, you have to write getters for all of those. Then you have to get getters for some of the player information. You have to write getters for like some of the other stats. You have to write bulk getters with pagination, because once you have all of these, tens of thousands of entities in the smart contract, your RPC endpoint is probably going to start rate limiting or throttling you. And so, this just becomes a whole nightmare, and your getter file swells to 500 lines of custom code. And there's just like all this weird stuff that you have to deal with. You write bulk getters with pagination, like I mentioned. The Solidity storage model is like really strange. So, if you want to like get all planets with a certain property, in accordance with a certain filter, you basically have to write like 3 new kinds of getters and chain them together. And you're doing like 3 asynchronous back and forths with your RPC. Okay, well, what about the client? So now, we've solved the problem of we can get planets, or at least the contracts have exposed interfaces for being able to pull planet data from the chain. Okay, well, great news, everyone. We are able to work with TypeScript instead of Solidity, so we're not just limited to 13 fields. So now we've got the planet interface over here. Now, there's a translation layer, unfortunately, that you have to write in between the client layer and the contract layer. So first off, we're going to have to write this decode planet function. We're going to have to replicate like every piece of sort of like semantic information about a planet that's encoded in the contracts also has to be encoded in the client. And then you're going to have to write translators. Those translators need all these utility functions. You need to be able to parse a location ID from a hex string, from a decimal string, from a big int, from an ethers big int. So for those of you who have used ethers.js, they use a big number serialization that is slightly different than the native JavaScript serialization. So when you want to add one field, like you want to add a new kind of spaceship, you're now interacting with about 7 or 8 different files here just to serialize and deserialize the spaceship. And you end up with this 800-line file contracts API, which is being used to bespokely convert between the contracts and the client. All right, and the final question here is, what about indexing? Well, as many people know, blockchain storage is pretty expensive, so we can't just store indices on chain, but obviously we care about index data. Well, if you Google search for Ethereum indexing in 2020 or 2021, the first result you're going to get is the graph. Which, if you look it up, it's an indexing protocol for organizing blockchain data and making it easily accessible with GraphQL. Well, great news. That's exactly what we wanted. Okay, so let's see. It turns out that in order to add these off-chain indices via the graph, here is the PR for adding, spaceships, space junk, and some various kinds of features into the subgraph. First of all, you have to write your indexers in this 2-year outdated version of WASM, which is called assembly script, of JavaScript, which compiles to WASM called assembly script. I don't know why it was 2 years outdated at the time. Like they were using a 2 years old version of assembly script. Unfortunately, it takes longer to index the chain data than the chain actually progresses. So if you have a 10-day round, it takes 14 days to index that data. There's also a token, and I'm not totally sure why still. And what this means also is if you make one mistake with assembly script, then you have to you'll deploy it to the hosted service. You wait 8 days for the indexer to run, and then find a bug, and you can't fix it on the fly there. You need to make the change and then start the indexing from the chain root. So yeah, I guess this is a problem that is now, I think it's safe to say well on track to being solved in a much better way. It is not too much additional complexity beyond defining this kind of schema to be able to define off-chain indexers with MUD. And there's other really cool projects as well, like Index Supply, which are building Ethereum to relational database toolchains, which just allow you to have all this kind of functionality out of the box with super high performance, orders of magnitude better, and in ways that we are familiar with programming. But all in all, there were many other issues: upgradability, rolling your own network code, maintaining Igor at XDAI and Gnosis Chain was helping us to maintain a fleet of RPC endpoints with a load balancer and stuff, stack too deep, using the entirety of the chain's gas limit. In general, it was a nightmare past a certain point to extend the game or improve on its complexity, which was, to be honest, quite minimal, even 3 years in. And behind the sort of back end of every, at some point, whenever new features would be introduced, oftentimes those features would be dictated not by game design decisions, but rather by simply what you were able to do with the toolchain that was available. So yeah, basically I think it's safe to say that, when you look back at this line in the MUD introduction, this revealed the need for a framework and a protocol to handle the inevitable complexity and to counteract the developer-unfriendly patterns in the way smart contracts are traditionally written. Safe to say this was a little bit of an understatement. And we had 3 years of experience to get really familiar with that. Okay, so I want to make a conclusion here. Hopefully that gives you some sense of the motivations behind various abstractions that you might have interacted with MUD and a lot of these modern day kind of application frameworks. This is a quote from some sort of report on on-chain gaming or blockchain gaming in 2021, which continues to be shocking to me that these reports were coming out because I don't think that there were games. The claim was that there were $4 billion invested to support the development and creation of blockchain-based games and their underlying infrastructure, which again is shocking to me because I have no idea where that $4 billion was going. In fact, Dark Forest and the very first version of MUD were built over the course of 3 years with under $1 million. And as far as I can tell, only the MUD architecture which began with ECS and then continued on to the various store patterns, indexers, etc., has seen any real usage either in MUD or the various derivatives that exist of it. And this is obviously a fraction of $4 billion. And the question is, why is it that from this era and category, this has been such a successful project with an ecosystem that seems to be organically arising? And as far as I can tell, it's because MUD is really the only infrastructure project from this era and category that came out of actually trying to build an app that people used. And so my message to Web3 here is build apps, build apps, build apps, build apps, build apps. Too many groups get swept away by this problem of building infrastructure. We're going to build great ways that you can interface with block space so that when people have things they want to do with block space, it's going to be really easy to do so. Well, you can't do that in a vacuum. And I think, this conference has been a really cool full circle moment and an example of how those feedback loops can kind of come to fruition. So this is the post-assembly question that I am leaving folks with. I think that Dark Forest team, we actually spent a little bit too much time siloed on the specific application, though I'm very grateful to the MUD team for continuing and just expanding far beyond what could have been imagined with that specific application. But I'll leave folks with the question, how do we know when it is time to move from application building, which is in a sense exploration, to infrastructure building, which is exploitation of the learnings that you've gotten? Thank you, everyone.